certainly a complex situation. As much as possible, I'm going to try and clean it up a little bit. So let's start with the endocannabinoid system. So this is a system that for lots of us didn't exist. We didn't know it existed when we first went through our training. So around, it's almost hit the 40, 50-year mark now, I think, that they uncovered what the base components of THC, of cannabis is. And then through that, they were able to look at what where this was affecting. And this is, of course, what they've now termed the endocannabinoid system. So they call this a retrograde neurotransmission system. And in the next slide, I'll kind of go over what that means. But in general, we're talking about something that is within the CNS and PNS of all animals, short of insects, and has a far-reaching effect. It alters a vast number of bodily systems. So immune system, cardiovascular, liver, gastrointestinal, it's quite across the board. In general, we talk about it being a relax, eat, sleep, forget, protect. This is their kind of main roles. So it's regulating motor functions, cognition, emotional responses, homeostasis, motivation. You're kind of getting the picture. It's a lot of things. So if we're now breaking it down into our three components, we've got our cannabinoids. So these are the ones that are naturally producing. This is what our body makes. The molecules, so EAE, 2AG, there's quite a few now that they're starting to uncover. They then are created and attached to our receptors. So these are what's termed our CB1 receptor, our CB2 receptor, and again, we're finding out more over time too. And then we have our enzymes that will degrade the original endocannabinoids. So this is a system that will sort of all-encompassing. So it will be made, used, and then degraded within that game. What we are talking about with medicinal cannabis is use of what they term as phytocannabinoids. So this is, unsurprisingly, cannabinoids from plants. And these guys are now directly playing with our CB1 and CB2 receptors. So if we kind of go now, what's happening with our CB1 receptor? We have a neuron and our terminals. An action potential will come down the said synapse, go across the cleft. The neurotransmitter will travel across the cleft. That will then trigger the ECB production, so the endocannabinoid production. So before that, it didn't exist, and only once the neurotransmitter has gone across it, they'll go, okay, now we'll make some. That will then go backwards across the cleft. So this is where they're talking about this retrograde neurotransmission, so going backwards. And from there, they will regulate the neurotransmitter. So it's effectively a stop button, a feedback loop that will support how much neurotransmitter can go across the cleft. The CB2 receptor is slightly different. So now we're talking about something that's found in all organs and structures associated with your immune response. So microglia in cells in brain, neutrophils, mast cells, macrophages, monocytes, lymphocytes. It's if a tissue or an organ is involved in the immune response, then there'll be CB2 receptors there. The CB2 receptor is a little bit less understood than the CB1 receptor. In general, we know that it will modulate the cytokine release, which then is how it is manifesting as this immunosuppressant, reduced inflammation, reduced pain.